Hello, hey, welcome to this tutorial on how to use BenchmarkDotNet, which is a benchmarking library you can use with C Sharp. So in this video, I'll try to show you how to use BenchmarkDotNet from the basics to some advanced features so you can start optimizing your code right away. BenchmarkDotNet is a very powerful tool for measuring your code's performance and finding areas to optimize. So to help you in that matter, to make you write more performant and optimized code, I'll try to provide some clear explanations and some code examples, simple code examples. And if you have any questions, just please leave them in the comments. I will be more than happy to help. So yeah, that's just it. Let's dive in. Okay, first things first. What I'm gonna do is to download the benchmark.net library first through NuGet. I will use NuGet and I will just use the writer as my default IDE. So you don't have to have the writer if you have any IDE that supports C Sharp. You can pretty much download any NuGet package and use it however you like. But in this tutorial, I will be using writer. So in writer, if I go tools, and NuGet and then show NuGet tool window, it will open a small NuGet packages window. So I will just write benchmark.net, and here it is the library. I'll just click this little plus icon and it's gonna install the package to my project. As you can see, it's installed. So the thing that I'm gonna do after install is to set the project build mode to release, because benchmark.net does not run in debug mode, so you need to make sure that it's in release. And the second thing is that obviously I'm gonna create a class. Let's call it benchmark tutorial, and I'm gonna add memory diagnoser attribute on top of it. What this attribute does is basically it marks your class as traceable by the benchmark.net library so that it can compare and benchmark methods, whatever you added in this class, and it can create a graph for whatever you added to this class. So we are ready to go. Let's just get started. Let's just write our first benchmark method, right? Let's call it public void string concat, right? And I'm gonna write, let's say, string temp. Let's start with empty string, right? And create a for iteration for 10,000 times. And I'm gonna use, let's say, string concat temp with small a, right? And let's also write public void string concat using plus. I'm just gonna copy whatever we have here, but instead I'll just get here and write a. So if I add benchmark attribute on top of it, it's just gonna trace how well and how performant this method does in your system, in your hardware, in terms of CPU usage and memory usage. So I'm gonna add it here as well. But before running it, we need to go to our main method, and I'm gonna add benchmark runner run benchmark tutorial. That's just it. Let's turn back here and press run. It just finished. As you can see, there is like a small graph. There is like multiple columns and two rows. Method is indicating the method name. Mean, error, and standard deviation is for your CPU timing. So it's like the mean time, the average time that string concat method took to finish is like 3.3 microseconds. And the error is also like 0.0 blah blah blah. And generation 0 and 1 means generations in your memory, and the lower is the better. So if you don't have like generation 1, generation 2, it means that your code is not keeping things alive so that it can just pass through the other generations in your memory. So let's just write another method to optimize our code, right? We are just trying to concatenate some strings. So let's write string builder test. I'm gonna copy this, but let's just write string builder, which is gonna be new string builder. And what I'm gonna do is to use append. And let's put the benchmark attribute again and hit run. Okay, as you can see, our second benchmark has also completed. So the string builder test is much more performant compared to string concat or string concat using plus. So as you can see, its processing time in the CPU is like very faster, and the US is like microsecond is like 1 millionth of a second. And as you can see, it took less memory space in generation 1 and generation 0. We saw that the string concat was not really performant, so we tested another method and we can see that it's way better. So that will help us to determine which methods are better or worse in our project, right? So what I'm gonna use here is another attribute, which is params. So in params, you can just write, let's say, 100 and 500 and 1,000, right? And we can just write private, yeah, int iteration count, and we can use this here, here, and here. So for every parameter we have here, the benchmark will run and compare every method to each others to see how they did for every parameter. So let's just hit run and see what happens. Okay, benchmark has completed, and we have the iteration count column, which comes from a field that we created with params attributes. So the thing is that, as you can see, the string builder is winner across all the iteration counts. And as you can see that the more we iterate, the string concat methods are leaking data through generation 1, which is not really good. But string builder doesn't do that across all the iteration counts. So that means maybe if we increase the iteration count, the first two methods could leak data into the generation second in our memory. But before that, I want to do something else, which is to talk to you about 4 more attributes in BenchmarkDotNet, right? So what I'm going to explain is that global setup and cleanup and iteration setup and cleanup. So global setup and cleanup, as well as the iteration ones, are attributes you can use to perform setup and cleanup tasks before and after benchmark runs. So the global setup is called before the benchmark starts, and the global cleanup is after the benchmark completes. This ensures that benchmark always starts with the same initial conditions, and that any resources used by the benchmark are properly disposed after it completes. So if you have any allocations that you have done, or if you have created any threads, tasks, whatever, you can make sure that they are just disposed or stopped after your benchmarking has completed. And same for the iteration setup and cleanup, but as the name states, they are called before and after every iteration of the benchmark. So this can be useful for initializing or resetting the states between iterations. So yeah, if I go back to my code example, I can just try to demonstrate the attributes here. First, I'm just gonna write global setup public void global setup, right? And I'm gonna create public. I'm just gonna skip this for you. And I'm gonna create a private list of strings. Let's just call it strings. And at the global setup, I'm just gonna initialize it, right? And at the global cleanup, I'm gonna make sure that this list is disposed properly. Dispose stuff here, right? And at the iteration setup, I want to just assign new list string big as the iteration count, right? And at the iteration cleanup, I just want to clear this list. Okay, now that we set it up, we can just try to run this method and see what happens, right? Okay, as you can see, the benchmarking has finished, but even though we have the results, the benchmark.net is complaining that it didn't have at least 100 milliseconds for each benchmark iteration so that it could create more accurate benchmark results. So to do that, I'm just gonna go ahead and add this attribute here, which is iteration count, and I'm gonna set it to 50. By default, it's 10. What this attribute does is basically increases the benchmark iteration time. It puts more workloads to the benchmark so that it can create, again, much more accurate outputs. I'm also gonna delete all those params, and let's just delete these two and put like 60,000 and 75,000 here, and yeah, hit run. Okay, as you can see, the benchmarking has finished and it's still complaining about the string builder test, string builder method, but I'm not going to increase the workload anymore because this method is quite fast. But as you can see again, it created the outputs for string concat methods using plus or string concat method, doesn't matter. So from now on, I'm just going to show a few more attributes and simple tricks to you so that you can, use BenchmarkDotNet more comfortably in your project. So before doing that, I'm just gonna delete all those iteration setup and global setup cleanup stuff. Write 100, 500, and 1000 again, and I'm just gonna delete the iteration count as well. Pretty much bringing the workload to where it was before. The first attribute is that order, which is gonna help you order your graph, the benchmark results, however you want them. For example, if you choose fastest to slowest, it's gonna order as it says, or vice versa, just like that. And on the other hand, there is this group benchmarks by, and for this you can just use benchmark logical group rule in num, so it can just like group your benchmarks by category, by job, methods, by params. So just remember that there was also by namespace, but I don't think that it's here anymore. So yeah, if you want to group your benchmarks, if you have like multiple benchmarks across your project, so if you want to run them and see everything like in a different graph, in a different result box, whatever it's called, you can also go ahead and use this one. And on the other hand, you can also use this invocation count attribute, which is basically how many times each iteration is going to be called. So for example, if you say 100, each iteration is going to be called for 100 times, like 100 times this, 100 times this, 100 times this, so that it can, again, like decrease the noise in your output, in your benchmark tests, and produce more accurate results. It's gonna help you. I would recommend you to use this one whenever you need. Also, if you wanna categorize your benchmark, you can write benchmark category, write like string operations, or just write like that if you want. And whenever you use the group benchmarks by category, this is gonna be your category for this class. So it's pretty much useful to see the outputs separated from each other. This is gonna help you in that case. Lastly, if you want to compare your methods based on one specific method, you can just go to the benchmark attribute, open the parentheses, and write baseline true. And on top of your class, you can just write baseline column and hit start. So as you can see, the benchmark has finished, and we have three more columns here: ratio, standard deviation, and baseline. So baseline means that, is this method the baseline method? No, it's not. Yes, it is. And ratio means that the current method's mean ratio to the baseline method's mean ratio. And yeah, that's just it. And as you can see, the results are ordered as we wanted it to be ordered from the fastest to the slowest, and it's also categorized like three categories. As you can see, they're not like joined all together. Yeah, so that's just it, guys. I just hope that you liked the video, and if you did, please like, comment, subscribe for more video. So thank you for watching. See you in the next video. Bye bye.